Now, continuing the idea from the previous page where I started compounding more frequently, if we increase the frequency of the compounding more, we'll earn very little additional money. Okay, we earn 7 cents extra by compounding every day instead of every week. If we compounded every hour, the amount we would make would be, additional money would be very small. So the maximum one could earn with $1,000 in 7 years at 3.1% interest, what I mean by maximum is the maximum if you compound it more and more often. You just keep compounding it more. So maybe you compound it every day, and then you compute, what if I compounded it every minute or every hour? And then what if I compounded it every minute? What if I compounded it every second? And you'll notice that the most that you could possibly make is $1,242.34. You can't ever make more than that, no matter how fast you compound. Okay? We call that an upper limit of the amount of money you can get. And that's only 1 cent more than compounding daily. If you look at the previous video, it was $1,242.33 if you compound. Wait, did I do weekly? I didn't do daily. But anyway, it only goes up 1 cent more. And that's no matter how fast you compound it. You can only gain 1 more cent over compounding daily with these numbers that I gave, with that initial $1,000 investment at that percent. So this is a graph of N against the amount A that you earn, given P is 1,000, T is 7, and R is 0.031. I'm keeping those constant, and I'm changing the N in the formula. So compound, N is the number of times you're compounding per year. And so as you increase the number of times you're compounding, the amount of money you get increases pretty quickly, actually, to this asymptote. It looks like it crosses the asymptote, but it doesn't really. It's just the way I drew it. It approaches this asymptote, and that asymptote is the equation to that is A equals $1,242.34. And that's why I know that that's the maximum I could earn. It never goes above that. Okay. Now, why is this important? Why am I talking about this? Because this is the number that you get if you use a different formula for compound interest. It's a formula for continuously compounded interest. Gives you the numbers as P, T, and R change. It'll give you the amount that would be this asymptotic value, we call it. Okay, so this is the function that this is a graph of. I graphed this function, A of N equals 1,000 times 1 plus 0.031 over N times to the 7 times N. Because it's 7 years, right? So the point is, after a while, it doesn't really make any sense to compound more quickly. That's one point. The other point is, there's a formula to figure out what this asymptote is. That's why I know the asymptote's there. And the formula is given by this. So some of you might have seen this as a compound interest formula. Okay, it's A equals P-E-R-T. E is some number. It's kind of like pi. It has a specific value. Engineers usually have this memorized to several decimal places, or they used to anyway. I don't know if they still do. Some do. Kind of like pi. Some people have pi memorized to 5,000 places or whatever. People do the same thing with E. This E is called Euler's number. E-U-L-E-R, Euler. Also sometimes called Euler, incidentally, both of which are actually correct. Different German in different countries. That's why there's 2 different pronunciations. So anyway, E is this constant. So the variables in this equation, A equals P-E to the RT power, the variables are the r, the t, the p, and the a. The e is not a variable. Now maybe your interest will be fixed. Once they tell you what your interest is, it becomes a constant, right? But here notice the exponent is rt, not that previously it was n times t, number of times per year that you're compounding times t. That no longer makes sense because this formula comes from, it's like if you were compounding infinitely fast, infinitely many times per year. So you can't obviously put infinity in there. So how that other formula turns into this is kind of a little bit complicated. I think the text goes into it. I don't really think it's that enlightening. It's just this is the equation that I used to find this, where this asymptote was of $1,242.34. Okay. It's kind of a shortcut way of computing your interest, just a simpler formula. As long as you realize that in some situations it's going to be, it is an approximation of what actually happens. Because nobody compounds interest continuously. They all do it the other way, and they just do it fast. So if you compound interest every second, it's going to behave almost exactly, unless you have an incredible amount of money, it's going to behave exactly like this simpler equation. So you as a consumer could calculate very quickly what your interest rate would be because maybe you don't care about 10 cents. If you're investing $1,000, maybe 10 cents doesn't mean too much to you, right? So I just pointing out, there's actually an E key on any scientific calculator. If you look for it, it's usually somewhere near pi, and it might even be the same key, like second or green or blue or whatever. Blue pi might give you E. Anyway, I would check it out and find it. It's on there somewhere because you'll need to know it for the future, okay?